Good evening, sir.
Good evening, sir.
Yeah, good evening, guys. Just a minute. Guys, those who are online, are you able to hear me?
Yes, sir.
Are you able to see the board clearly?
Yes, sir.
Okay. Good evening, guys. We'll get started. So, what was the last topic we were discussing? Drift velocity, right? So let us recollect the concepts even before we step into the next part. First thing that we saw is what is electric current, right? So under electric current, we saw two different concepts. What are they? One is called as instantaneous current and average current, right? Then we saw how the electrons are going to flow within a conductor. So initially, when you take a metallic conductor, due to temperature, how will the electrons be present? Are they going to be at rest? What will happen to these electrons? Are they going to be at rest? So they will be in some random motion. Why is this happening? It is because of the thermal agitation. So due to the thermal agitation, can I say that all these electrons are in random motion? But if you take the same system and connect it across a potential source, right? Where we connect it across a potential source, what is going to happen? When you connect it across a potential source, all these electrons will start getting drifted in a particular direction. You guys remember this? And why is this happening? Check your notes, you will get the idea. It's going to happen because of the electric field that is getting generated. So electric field will get generated from higher to lower potential, and the electrons are going to get drifted in the direction opposite to it. Is that right? So what will be the value of force experienced by these electrons? E into capital E. Why is it so? Because force experienced by a charged particle placed in external electric field is Q into E. And this will be equal to how much? Mass into acceleration. So A will be equal to E into capital E divided by M. Is that right? Yes. E into capital E divided by M. And all the electrons will start getting accelerated in the opposite direction like this. Okay. So till here we are clear. And the next concept that we need to understand. What will happen to the velocity? So initially, if you take the velocity of each electron to be U1, U2, U3, so on till Un, right? Then what is going to be the average initial velocity? U1 vector plus U2 vector plus U3 vector plus so on till Un vector, the whole divided by n. What is this called as? Average initial velocity. This is equal to 0. I hope you remember this, right? Now the next concept is what is going to be the velocity of each particle. So V1 is equal to U1 plus AB, or I'll call it as AB1, right? And V1 vector, can I write it like this? U1 vector plus A vector times T1 vector. Similarly, V2 vector will be equal to U2 vector plus A vector times T2. So when you keep writing like this, the velocity of the nth vector, the nth electron is going to be U n vector plus A vector into Tn. Right. Now when you add all these values, V1 vector plus V2 vector plus so on till Vn vector, what are you going to get? You will get U1 vector plus U2 vector plus so on till Un vector plus A into T1 plus T2 plus so on till Tn. Correct? So whatever is supposed to do, divide it with n on both the sides. When you do this, what are you going to get? You will get the average of all the initial velocities summed in this value. 0. What is the average of all the final velocities? You call it as drift velocity. Correct? So Vd is equal to A into the average of all these values is going to give you something called as tau. What does this tau stand for? It's called as relaxation time. So what is this relaxation time defect? It is a time that is existing between two successive collisions. Did I give you the definition or not? I gave you this one. Huh? Okay. So drift velocity is equal to acceleration into time. So Vd is equal to, what is the value of acceleration? Small e into capital E divided by m into tau. Correct? So if I have to write it in terms of vector, then I write it as Vd vector is equal to minus of E into E vector divided by m into tau. Is it clear? Right. So what does this tell us? That the drift velocity and the electric field are in opposite directions. Okay. So we'll have this point in mind. Okay. Now write down the definition for relaxation time. Write down the definition for relaxation time. It is defined as a time. It is defined as a time existing between two successive collisions. So the time existing between two successive collisions. Okay. The expression that we wrote is PD will take only the magnitude of it. Small e into capital E divided by m into tau. Right. Now, if I take current, okay, if I want to define, write down the next heading. Current in terms of drift velocity. Current in terms of drift velocity. So we know that current is equal to what? Q divided by dm. Is that right? So if I take the same conductor, again the conductor is going to be in a cylindrical form. Let us say that the area of cross section of this conductor is T. So what is it? The area of cross section is T. Right. What are present inside? You have electrons. So what is the charge of electron? It is E. Is it clear? Now, let the number of electrons per unit volume be smaller. Are you able to understand what I'm trying to say? The number of electrons per unit volume is smaller. So can I write this as the number of electrons divided by the volume itself? Is that clear? Right. So this is also called as number density. This is also called as number density. And if I take the length of the conductor to be L, okay, if I take the length of the conductor to be L, then how can I write small n in terms of capital N? Small n is equal to capital N. So remember in physics, right, there are two n's that are used always. Small n is generally used for number density, and capital N is always used for numbers. So it's not only with respect to this chapter, it is with respect to every other chapter as well. So I repeat it, small n is generally used for number density. Here, what are we trying to see? The number of electrons per unit volume. Right? So capital N is the number, just the number. Here, so capital N divided by what is going to be the volume of this conductor? It is going to be 8 to 10. So what is going to be the number of electrons here? It is small n into A into L. Let this be 1. Let this be 2. Okay. Is it clear? From 1 can I write I is equal to Q by T is there, right? How will you use the quantization of charge to write the total charge of this? It is capital N into E divided by T. Can I write it like this? Think about it. Can I write it like this? Right. So, but what is capital N base?
Integral multiple of
small n into A into L into E divided by T. Right up. Now see. So what I'm going to do is N I'll combine with this E and A and I'll write this L by T separately. Okay. So I will be equal to N into E into A into L divided by T. What is the distance traveled per unit time called as? So can I call this as the drift velocity? So this will be equal to NEA dt. Okay. This is what is called as NEA dt. So whenever you want to write current in terms of drift velocity, you write it as small n into E into A into dt, where small n stands for the number of electrons electrons per unit volume. E is the charge of the electron, A is the cross section, sorry, area of cross section, and B is the drift velocity. Any doubt, guys? Here. You guys saw the updated syllabus. Potentiometers. I don't think anything from the first chapter. So clear with this? Shall I proceed?
Could you
So
tell once again what is capital M? Sir, could you tell once again what is capital M?
Hello. Is someone speaking? Guys, those who are online, any doubt? Shall I proceed?
Yes, sir.
Okay. So we got this thing, right? I is equal to small m into E into A into B. Now what you can do is if you bring this A to the left hand side, then it becomes I divided by A is equal to NE into B. This I divided by A. What are you able to see? The amount of current flowing per unit cross sectional area. This is called as, any guess? Can you give a name to this? Current? Nice. It's called current density. Okay, so current density is equal to NEA into BD, and current density is generally represented by the simple G. Okay. And remember, current density is a vector quantity. Current density is a vector quantity. So if somebody asks you to define current density, how will you do it? The amount of current flowing per unit cross section area. Always use the word unit, which for whichever term is in the denominator. Current flowing per unit cross section area is called as current density, and it is a vector quantity. Right. So next one is a very important one. Observe. Okay, I'll leave some space for the heading. I'm not going to tell you what is it. You are going to guess it. Right. So this is the next derivation. We are going to start like this. We know that drift velocity is equal to how much? E into capital E divided by m into tau in terms of magnitude. Is that right? So E into capital E divided by m into tau. Similarly, I is equal to NEA B. So if I take this value and I plug in here, then what is going to happen? It is NEA into what is the value of ED base? Small e into capital E divided by m into tau. So this will be equal to NEA square A into A divided by M into E into tau. N E square A divided by M into E into tau. But how can you write electric field in terms of potential? What is the relation between them? Electric field is called as a negative or something. Potential? Yeah, E is equal to minus dV by dr, right? What is the dV by dr called as? Potential gradient. So if I write it in terms of magnitude, can I write it as V divided by L? Where if I take this conductor, right? For this conductor, you are applying a potential difference of value V across length L. So can I write this as N E square A divided by M into V divided by L into the right. So this is equal to I. Now look at the way I'm going to rearrange it, right? This implies I'll leave B this side. Okay. I'm leaving B this side. So B I can write it as M into L divided by N E square A into the this whole thing multiplied with I. So first write it down. B is equal to M into L divided by N E square A into tau. Yeah. This is all about the derivation. How is it looking? Look at this expression. I've segregated things that are P stands for potential and right stands for current. So what are the one in the bracket? Yes, sir. What is it? Yes, sir. Resistance. Okay. So what is that? This is what is called. So there is actual derivation for Ohm's law. Okay. So from this can I write P is equal to I into R where R is equal to how much? M into L divided by N E square A into M into L divided by N E square A into tau. So can I write this as N divided by N E square tau into L divided by N E square, sorry, M divided by N E square tau into L divided by then R is equal to something into L divided by A. What is it? Recollecting from your 10th standard. There is an expression. R is equal to rho into L divided by A. You guys remember this? What does rho stand for? Resistivity. Okay. So this is the expression for Ohm's law. There is the expression for resistance, and this thing is the expression for resistivity. Make a note of it.
Sir,
Here,
sir,
done. Yes. Now tell me, what does Ohm's law state? So at constant temperature, potential difference is directly proportional to current. So we are using the word at constant temperature, right? Why are we doing it? So due to thermal expansion, length will vary, area of cross section. That is right. So when you are saying this, right, you write it as V is directly proportional to I. Then V will be equal to I into R. So R is introduced as what? As a constant of proportional. So if it has to be constant, it should be independent of all the parameters on which, all the parameters which would change the value of it. What would be one of the parameters that can change the value of it? It is the temperature itself. How we told, the resistance can vary the length and area of cross section. Along with that, the speed of the particles will also change, due to which the relaxation time will decrease. Right? When you supply temperature, what will happen to the speed of the particles? Will they increase or decrease? When you increase the temperature, the speed of the particles will increase. That's what kinetic theory tells us. Right? When it is going to increase, the time between two successive collisions, will it increase or decrease? It will decrease. So when it decreases, tau will decrease. That is why if you observe, resistance for a metallic conductor will increase with temperature. That is why when you do experiment, right, you have Ohm's law experiments. Have you done it in the lab? Okay. When you do it right, they say that you should not keep the apparatus on for a longer duration. When you keep it on for a longer duration, what will happen? Heat will get generated. Due to heat, what will happen? Resistance, which you are trying to measure, will not be accurate. Suppose if you go and see, right, at the back of the wire, if it is given 5 ohm, when you try to measure it, it is somewhere around 5.1 or 5.2. You will not even have minimal error. You have maximum error. Okay. Depends on how much time you keep it on. This happens only for a metallic wire. Only for conductors, I repeat it. So the resistance of conductor will increase with increase in temperature. Now you are able to connect all the dots. This is the reason why they told that constant temperature alone Ohm's law is applicable, because R will not change when the temperature is kept constant. Okay. So what about resistivity, guys? Rho is equal to N divided by N E square tau. So when I ask you, you told me resistance will change because length and area of cross section are changing. Now the question is, will the resistivity of the conductor also change with temperature? Look at the expression. Yes, it will change. Why? It depends on the relaxation. So the resistivity is, the temperature is going to increase. This value, relaxation time will decrease, and the resistivity will increase. So what I'm trying to say is, resistivity is also proportional to temperature. It increases. How it will increase, that is a mathematical expression that we'll discuss next. Okay. So I told you, I'll give you the heading, right? This is what is the derivation of Ohm's. So how did you derive it? You use two expressions. What are they? They ask you to leave some blank space in the beginning, right? Write on the heading there. Derivation of Ohm's law using the relation between current and drift velocity. Using the relation between current and drift velocity. Clear? So these are the important basics for question. Right. Next is about the temperature dependence of resistance. So write down the heading as temperature dependence of resistance. So R is equal to R as a writing like this. Right? Ti if resistance is Ri, where Ti stands for initial temperature, Ri stands for initial resistance. And at Tf, let the resistance be Rf. This is clear. Right? So R final is written as R initial into 1 plus alpha into delta. Perfect. Sorry about this. Yeah. So R final will be equal to R initial into 1 plus alpha into delta. Guys, are you able to hear me?
Yes, sir.
You're online, were you able to hear me?
Yes, sir.
Okay, you could follow till this point, right? Whatever I told. Good. Tell me. When you not variable. That's not a part of the syllabus. Let's not worry about it. It depends on how the length will vary, area of cross section vary, and right? Okay. So shall we try out one problem based on this from your textbook? See where the temperature dependence of resistance is there. So go to page number 105, example 3.3. Page 105, example 3.3. So what is the question? Did you read it? Can someone read that out?
Uses neutron for its heating air and a negligibly small current passes which resistance at room temperature is found to be 75.3.
Okay. So resistance at room temperature, I call it as Ri. So Ri is how much? Ri is
75.3.
75.3. What is the temperature? So initial temperature is 27 degrees Celsius. Okay.
When the toaster is connected to a 230 volt supply, the current settles after a few seconds to a steady value of 2.68 amps.
So current is equal to how much? 2.68 ampere. Okay.
230 volt supply.
So V is equal to 230 volts.
What is the steady temperature of the equivalent?
So T final is equal to how much? If you observe this problem, right, there is some data that is written. Did they give you the value of alpha? See, alpha is not something you can find it from the mathematical expression. It is constant for a given wire. What is the value of alpha given?
1.7 10 power minus.
Alpha is 1.7 into 10 power minus 5 minus 4 per degree Celsius. Or degree Celsius into 4. So if you want to find the final temperature, how can we do that? So we have the expression, right? R final is equal to R initial into 1 plus alpha into delta T. So do we have R final value in our hand? Well, so if you read the question carefully, they are asking what is the temperature at which this value is getting attained? What is the steady temperature at which this kind of condition is achieved? So what is steady temperature, steady current that is flowing 2.68? Steady voltage is 230 volt. So 230 divided by 2.68 will give you R final. So 230 divided by 2.68 is equal to R initial is 75.3 into 1 plus alpha is also given, which is 1.7 into 10 power minus 4 into what is the temperature? T final minus T initial. So T final is what we need to find minus T initial is 27. Right? Now I have a question. Had they given this in terms of per Kelvin? Okay, had they given it in terms of per Kelvin and the temperature is given in terms of degree Celsius. Do we need to do the conversion from Celsius to Kelvin or we can solve it as it is? We can solve it. Why?
Because let's say 100 degrees Celsius and 0 degrees Celsius. When we subtract both, we get
The 273, whatever you are adding, will get cancelled. That's all. So this is one important point. Okay. Whether they give the temperature in terms of degrees Celsius or Kelvin, right? And alpha is in terms of per degree Celsius or per Kelvin, you can still do what? You will not do any conversions. Okay. So one unknown, one equation, you will be able to find the value of Tf, right? So T final is equal to, so we can do it. That's up to you. Is that clear? Clear? Guys, those who are online, is it clear?
Yes, sir.
Yes, sir.
Okay. Shall we move on to the next concept? Yeah.
The beginning, what you told is
Potential lever. Last topic of this chapter. Okay. Now we move to the next concept, that is resistors in series and parallel. Okay. We go to this concept. There are resistors in series and parallel. So first we will see what do we mean by resistors in series. So when you say resistors are connected in series, when
current is constant.
when current is constant to all the devices, you say that the resistors are connected in series. So if I take three resistors R1, R2, and R3, R1, R2, and R3, and I connect it across a potential source like this. Okay. Let's say the current flowing in the conductor is through this circuit is I. Now the same amount of current is going to go through R1, R2, and R3. Right? Now if I draw the equivalent circuit of this, then how will it look like? Then I need to replace all the resistors with one resistance. R, S stands for series, and you have to connect it across the same potential source B, so that the current flowing through this circuit is also I. Is that clear? So what do you mean by equivalent in the first place? Replacing all the devices with one device which has the same functionality. Fair enough? Now tell me, according to Ohm's law, what would be the potential drop occurring across the resistance R1? So V is equal to what? IR. So current flowing through this resistor is I. The resistance of this is R1. So what will be the potential drop here? V1 will be equal to IR1. What about V2 guys? And V3 guys? So this I call it as V3. Now the question is, what is the relation between V1, V2, V3 and V? V is equal to V1 plus V2 plus V3. Correct? Now tell me one thing. What is V from here? Well, there is only one potential source. So V is equal to I into Rs. So can I take all the values from there and put it here? So I into Rs will be equal to IR1 plus IR2 plus IR3. So Rs will be equal to R1 plus R2 plus. So if you have n number of resistors connected in series, what would have happened? The resistances would have got added. Here, now what about resistors in parallel? When the voltage across all the devices, can I proceed by the way? Right. So resistors in parallel When can you say they are in parallel? When the potential drop across all the resistors is the same. So how should the circuit look like? So if I take the current supplied by the battery to be I, and let me call this R1, R2, and R3. Then what will happen to this current is, it is entering this junction. It will get split, right? Some current will flow through this I1, and remaining current will flow through this. And some current at this junction, whichever is coming from here, will get broken here, and here I will call it as I3, right? Now, what is the value of I1? I1 is equal to how much? The potential drop across this resistor divided by the resistance of the turns. So I1 will be equal to V divided by R1. Here I2 will be equal to V by R2. Here I3 will be equal to V divided by R3. Okay. Now, here I is equal to what? RS should be changed to RB. So here I is equal to V divided by RB. Now tell me what is the relation between I1, I2 and I3. I is equal to I1 plus I2 plus I3. Correct? So I1 plus I2 plus I3. What is I, guys? V divided by RB is equal to V divided by R1 plus V divided by R2 plus V divided by RB. So V will get cancelled. 1 divided by RB will be equal to 1 by R1 plus 1 by R2 plus 1 by right? Suppose I give you 3 resistors, 1 ohm, 2 ohm, and 3 ohm. Okay, I am giving you a task where you need to connect these devices in such a way that the final resistance should be greater than all the individual resistors. Then you will connect them in series. So, if, next task is I am giving you a task where I want you to connect in such a way that the value of final resistance should be lesser than even the smallest value of resistance is given. You will connect them in parallel. If you want a value between the highest and the lowest, you need to have a series and parallel. That's called as mixed connection. Okay. For example, all these devices, are they connected in parallel or series with this? These two plates will be parallel, right? Series, even if one stops working, the other will stop working. Have you ever tested it? Has anyone tested? Yeah. Oh. Stop working. But if you cut one, the other two will work. That's right. Great. So they have their own applications. Our concern is not about the application, only the basics. Right? So shall we try out the problem? Is there any example problem given here? Check that. Now, example 3.5 can be tried. So example 3.5, page number 112. Okay, before that. Guys, those who are online, any doubt?
No, sir.
Good. So we'll do this problem for today. What does 3.5 tell you? A network, something is written. A network of resistors. Okay. See, forget about internal resistance as well. Okay. You treat it as an external resistor. Okay. Now listen. Can you let me know the network is? You have resistance. Yes, what is the 16 volt? This 16 volt, this 1 ohm, right? This 1 ohm is the internal resistance. As of now, let's not worry about the internal resistance part. We'll read this also as an external resistance. Okay. Now, how much is this value? 4. This one? 1. 6. 6 and 12. 6 hours. Okay. Now tell me one thing. You look at the circuit, right? What are they asking? So they would have put some question, right? Equal. So equivalent resistance X. And in each resistance. This is what they are asking. So they are expecting the current in each resistance. So is this a circuit where everything is connected in series or parallel? It's a mixed connection, right? So if I look at this, right? If I look at this point AB, then what are the resistance across device AB? So how is this 4 ohm and this 4 ohm connected? Obviously, we are able to see it, right? They are connected in parallel. So what will be the equivalent resistance? So 1 by RP will be 1 by 2. So RP will be 2. It will exactly become half of it, right? So can I say here the resistance becomes 4? You guys want me to calculate and show it? So whenever generally two resistors are there, right, you can use this formula. RP is equal to R1 R2 divided by R1 plus R2. One common mistake that happens is people forget to take the reciprocal. Don't do that mistake. And one more thing is, whenever two equal values of resistance are connected in parallel, the value will become divided by the number of resistors. So here it is 4 divided by 2. For example, if there were 3 resistors of 4 ohm connected in parallel, value would have been 4 by 3. 4 by 4. Like that it keeps on going. R divided by N. So here it is 2 ohm. And here it is 1 ohm. And what about this way? If you use this formula, 12 into 6, 72 divided by 18. 72 by 18, 4 ohm. Right? It is connected across another 1 ohm resistor like this. Can I put it here? Does it make any difference? No, right? This is 4 ohm. Now tell me, 2, 1, 4, 1. How are they connected? Series. 3 plus 4, 7, 7 plus 1, 8. And here it is 16 volts. So R equivalent in this case is going to be 8 ohm. And what about the current? I is equal to V by R. 16 divided by 8. So this battery of 60 volt is supplying the current of 2 ampere to this whole network. So out of the 2 ampere that is being given by this battery, how much is consumed by each resistor is what the next question is. So for us to find that value, what do we need? Even before we understand how this current of 2 ampere is getting split, we first need to understand what the potential difference across each set of combination. So this is one set, one, and two. Now tell me one thing, across this one ohm and this one ohm, what would be the value of current? 2 ampere, because they are single resistors. So where will the headache start? We have this part and then, right? So if I take the potential drop here as V1, here I call it as V2, here I call it as V3. Okay. Actually, we did not do this, but I'm just telling you this. So if current I is going like this, right? Now, how much will be the current that is going here? It will be I1. Then what will be the current that is going into the other device? How much will be the current here? I minus I1 can I write it? Because if I write it as I2, what will I write? I1 plus I2 is I. Instead, can I write it as I minus I1? Is there anyone who is not able to understand this? Is this point clear? So what is the value that we know? Do we know I or I1? You know I is how much? 2 ampere. Right? Now listen to this. What is the potential drop across this 4 ohm resistor? What is the potential drop across this 4 ohm resistor? Will it be 16? Obviously not, right? Because the 16 will get split across each node, such that the sum of all the potential V1 plus V2 plus V3 plus V4 is what is 16. But I know one thing, that they both are connected in parallel. When two devices are connected in parallel, what can I equate? I can equate their potential differences. So according to Ohm's law, if you know the current to a device and the resistance of the device, multiplying both will give you what? Potential difference. So can I write 4 into I1? Listen. Can I write 4 into I1 is equal to? Why did I write 4 into I1? I1R is equal to I minus I1 into 4. Am I right? Did you understand what I did? So I equated the potential drop across AB, stating that the potential drop across this 4 ohm resistor and this 4 ohm resistor will be the same. So how much is the value next? 4I1 will be equal to 2 minus I1 into 4. 4 and 4 are gone. So 2 times I1 is equal to 2, which implies I1 is equal to 1 ampere. Isn't it obvious? Isn't it obvious when 2 amperes of current is going through the same values of resistance, it gets split into 2 equal halves. 1 ampere into this and the other ampere into this. In a similar thing. How can you, when I give you 2 minutes time, can you find out what is the current to each resistor here across balance? 4 by 3 and 12 it will be 1 now. 2 by 3. So 2 by 3 is 0.6, 4 by 3 is, so it's greater, correct. So don't write I1 and I1, write it as I2 and I minus I, because we are using different notation. So, anyone else who got the answer? What about it? Got the answer? I asked about this. Well, I2. So if I take this as I2 and this as I minus I2, then what will you write as? 6 into I2 is equal to 12 into I minus I2. This and this will get cancelled. So I2 will be equal to 2 into 2 minus I2. So I2, or rather the correct I2 is equal to 4. So I2 will be 4 by 3 and I minus I2 will be 2 by 3. Okay. 4 by 3 ampere, 2 by 3. Clear? So this is all about the resistance in series and parallel. Okay. So in the next class we will discuss about what will happen about the internal resistance cells and an important topic called as electromotive force, which is very, very important. You have not heard the term till now. So after that you have cells in series and parallel. Kirchhoff's law, each one will be that we are done with small chapter actually. Okay. Next chapter is slightly big. So any other doubt from today's class? Everything clear? Guys, those who are online, everything is clear?
Yes, sir.
Yes, sir.
Okay. So that's it, guys. We can wind up.
Thank you,
Thank
sir.
you, sir.
Yeah.